Okay, so good morning, everyone. In the today's session, we'll discuss about the clustering techniques. Clustering technique is basically useful to identify the similar group of object. It is very helpful for big data so that we can identify the required data set. Clustering techniques can be hierarchical clustering, where cluster collection of similar object into groups. Each cluster is distinct from each other cluster, so every cluster has a different attributes compared to other cluster. They can be broadly similar to their attribute, but there are some distinct attribute between the cluster. Objects within each cluster are broadly similar to each other. So, when we talk about the whole complete data set, they are generally similar to each other. They have the similar attribute, but when we're defining them into a cluster, so what happened? The same attribute items are grouped together, and they have some distinct property compared to other cluster objects. Uh, in a cluster, the process is where we identify the similar group of object, and then we try to find out the object which belongs to any other clusters or not. So the object which is having the most similar properties to any cluster, that object is separated or belong to that particular cluster. Otherwise, the object will be assigned to different clusters. Clustering techniques. So the distance between two clusters has been computed based on the length of a straight line drawn from one cluster to another. So that can be one basic assumption. If we have able to identify the distance between the two different objects, then we can identify the correlation between the object. The object which have a more less distance compared to other objects, they can be grouped together. These distance is not is called as a Euclidean distance because it is computed as a Euclidean, and this is not a straight line that we have computed for our x and y axis. Apart from the Euclidean distance, many other distance metrics can be also be used to identify the clusters. The choice of distance matrix should be made based on theoretical concept from the domain of study. So whatever the your domain, you have to make sure that your distance matrix must satisfy the requirement of the cluster as well as the domain. In a distance matrix, basically we'll define the similarity in the way so that we can measure that particular similarity between the objects. Okay, this is an example. So take a 1 minute time and please go through this paragraph. Okay, now so clustering methods used to identify groups of similar objects in a multivariate data set. For example, marketing, biomedical, and geospatial. Uh, there are different types of clustering methods. So these are some list of I have listed down some clustering method. These are the method partitioning method, hierarchical clustering, fuzzy clustering, density-based clustering, and model-based clustering. So in a partition method, we'll divide the data set into different partition based on their similarities. Hierarchical clustering will divide the clusters in a hierarchical model. In a fuzzy clustering, we'll apply the fuzzy logic while defining the fuzzy clustering. Density-based clustering will identify the object based on their density matrix and so on. You can also refer the source of information where you can find out the different types of clustering method. Okay, so let us discuss about the k-means, one a common example of clustering method. If you gone through this picture, you will identify that this picture is representing various vegetables. Then what the k-means does, it will identify the similar object into a different cluster. So you can find out that here, whatever your object is, that object is uh, partitioned into the different object. So based on the above picture, it is quite uh, feasible by using the clustering method k-means, so that we can identify the similar group of objects, and we can identify the vegetable from the group of vegetables. Now, K-means clustering is an unsupervised machine learning algorithm. It means there should not be a labeled data. So whatever the data is the data set is provided to us. We have to apply the unsupervised method. It will group the similar object in the form of cluster. Number of group is basically represented by the K. So here K means a K will represent the number of groups. Find the similarity between the item and group them into the cluster. So basically, K-means can apply the Euclidean distance or other distance matrix to find out the similarity between the groups of items. To calculate similarity, Euclidean distance is used as a measurement. If you define the Euclidean distance, it is the distance between the 2 points, either in the plane or xy axis or three-dimensional space. Measure the length of segment connecting the 2 points. Okay, so for further discussion about the Euclidean distance, you can follow this link where you can get the more information about the Euclidean distance. This is a pseudo code of k-means algorithm. So we can initialize k-means with the random values. So initial we'll define k as any random value, and then for given number of iteration, we go through the each and every item given in the data set and find out the similarity distance matrix between the k random value assigned k and as well as the object, and whoever has the closest value to the item, assign item to the mean and update the k. Okay, so I have taken an example where developer has provided a simple k-means clustering using the Python. So you can refer this URL, and there you will find the complete information about this code. So basically, this code is written in Python 3.5 and NumPy 1.110. And the description of as such, the k-means clustering is one of the most popular method for data mining, and it is an unsupervised machine learning algorithm and so on. So in this code, in this program, we'll see how the k-means will work. So this is our data set where we have a different kinds of data set having a different values. Then we'll apply the k-means clustering technique. So we'll define various functions inside the Python. Now, for example, computing the equivalent distance, assigning the label cluster, computing the new centroid. Centroid is represented here as a key, and iterate the k-means. After applying running this code, you can also run this code on your Jupyter notebook. You will get this kind of result. So you will get a different clustering with their clustering number as well as their data point. Further, for the k-means, you can refer these resources. Sorry for the typo error here. You can refer this article, k-means clustering algorithm application from towards data science. You can also refer the k-means clustering introduction from Geeks for Geeks, and you can also refer the k-means clustering from Wikipedia. Now, let us discuss about the clustering of high dimensional data. So when we talk about the high dimensional data, it means that particular information has a various attribute, and when we want to scale those attributes, we have to take the multi-dimensional approach. So please go through this paragraph for 1 minute. Okay, so you can find out that multiple dimensional, higher dimensional data will produce a problem that is called the curse of dimensionality. So it is very hard to compute the desired output from the higher dimension data. So we have to reduce the dimension of the data to so up to the so that we can get a more better output. Okay. Clustering high dimensional data is the cluster analysis of data with anywhere from a few dozen to many thousand of dimensions. And these such high dimensional spaces of data are often encountered in areas such as medicine. So if we talk about medicine, then you could find out that a simple medicine can have a thousand properties. To map those properties, you have to take the high dimensional spaces. Another example is clustering of text document. So in a text document, you want to cluster the document and a large number of document into different clusters. So you have to apply the clustering technique, and it will require the large dimension of cluster. So it may be possible that you can create, you will able to find out the large number of clusters of text document due to their different properties. A word frequency vector is used, the number of dice equals the size of the vocabulary. So I will suggest you that when you go for the classification of the text document, you will find out this that when we define the dimension of the word vector using the text classification, the size of the text word vector will be equal to the size of the vocabulary of the document. So that can be a high dimensional now. So clustering high dimension data will go to the one first algorithm that is a clustering in Quest. It is also referred that link. So let me open this link. So clustering in Quest or Click is given by the Agarwal and Sigmoid in 1998. In this approach, they have divided a data set into subset where objects in the same subset are similar to each other with respect to the given similarity measure. Clustering can be used to better understand the data mining, pattern recognition, information retrieval, machine learning, and so on. Clustering techniques basically can be divided into a partition, single level where each and every cluster are in the same level, or in a hierarchical level where multiple cluster can form the more higher level of clusters. Distance-based k-means or connectivity-based, graph-based, or group-based approach can be applied. A special case of high-dimensional data are irrelevance of distances, sparsity of the data, local feature relevance. So these important points must be considered when we are dealing with the higher dimensional of data. So this is one data case where they have defined data set into different clusters, and they have defined a subspaces for the different clusters. This is again a second example of data cases where they have mapped the age and age group and the corresponding salary. So you can find out that in the base of this, if you want to cluster data, you can define into two clusters, C and D. So where D can have both attribute of age and the salary. So you can see here that the higher salary will not also depend on the age. So it may be possible that at a lower age, a person can get a higher salary, and a higher age, a person can also get a higher salary. So click is basically a density-based and grid-based subspace clustering algorithm. So in a grid-based, it discretizes the data space through a grid and estimate the density by counting the number of points in a grid cell. And in a density-based approach, it will take a maximum set of connected dense unit in a subspace where a unit is dense if the fraction of total data points contained in that unit exceed the input model parameter. So let us. I will suggest you that you go to the service-based clustering. A service-based cluster is a set of neighboring dense cells in an arbitrary space, and automatically identifies service spaces of a high dimensional data space that allow better clustering than original space using the a priori algorithm. Okay, so this is a bottom approach. I will leave it to you that you can go through this whole document and find out what is that. Okay, so these are the major step in for the click algorithm. So first it will identify the subspaces that contain the cluster. In order to identify the subspaces, it will partition the data space and find the number point that lie inside each cell of the partition. And it will apply the a priori principle to find out the subspaces that contain the cluster. It will identify the cluster, so it will determine the dense unit in all its subspaces of interest and determine the connected dense unit in all subspaces of interest. General minimal description of the cluster. So it will define the what will be the minimal description of a cluster. So it will determine the maximal region that cover a cluster of connected ends and determine a minimal cover for each cluster. So these are the some strength and weakness of the click. So I will suggest you that you should go for that. These are the few reference points that is taken to make these references. Okay. Let us go to the another link. So if you go find out this article, you will find out that it is a big original paper which is provided the click approach. So it you can go through the whole paper and find out what is a click and all about. And I will suggest you that please write a one-page summary of this paper and submit it as an assignment. Okay. Let me go to the next point. Okay, so we have covered the click. Another popular algorithm is a Proclus. So Proclus is a projected cluster. The Proclus algorithm works in a manner similar to k-medoids. Here, let us clarify the medoids. So medoids are representative of the objects of data set or a cluster with a data set whose average dissimilarity to all objects in the cluster is minimal. So basically, medoids are similar to calculating the mean or centroid or average of a data set, but they are slightly bit different from the means. So initially, we'll set a set of medoid of size is proportional to k is chosen. So again, what we'll do in a k means, we'll do the same thing here. We'll take a set k medoid, and that can be a random number. Then medoids that are likely to be outlier or part of a cluster that is better represented by another medoids and we move until k medoid or left. So after selecting the medoid, what will you do? We'll find out that a particular medoid has been selected, is it an outlier or a part of a cluster? It is a part of cluster, it will be included in the cluster. If it is an outlier, it is not inside the cluster, it is not satisfying the property of the clusters, then it will be removed from the central cluster. So I will suggest you go through this link and further study about the clustering Proclus and so on. Okay. Now our next topic is a frequent pattern-based clustering method. So for this, I will go through this some link. Let me open this URL. Okay, so for this topic, I will suggest you that please go through this paper and write down a one-page summary about this. So basically, we have already covered the pattern mining when we have discussed about the starting of this unit 4. So we have find out the particular pattern, a similar pattern occurred inside the data set. We have applied, learn about some algorithm on that. So you please go through this URL and find out what will happen here, how to find out how the author is trying to find out the frequent pattern mining. And you can also go through this topic. This paper is taken from this reference. So if I will download this PDF, let me download this PDF. So it is another paper, and I will suggest you that please go through this also research article and write the one-page summary about the frequent pattern mining. Okay. Now, the next topic is clustering in non-Euclidean space. So earlier we had discussed about that when we will define a clustering, we'll try to find out the Euclid distance between the similar object. So if they have a lower Euclid distance, they will group in the same cluster. Otherwise, they will be discarded from the clustering. So when we talk about clustering in a non-Euclidean space, the problem is that we use the distance measures such as mentioned at the beginning. So we can't base distance on location of the point. So now we can't take a distance between the two data points as a measure bit because we are not referring Euclid distance. This content is taken from this URL. Please go through this PPT and we'll get please get a uh, more information about the clustering. So to overcome this problem of non-Euclidean space, we can find out some approaches. So author has discussed some example. So suppose we have to find out the distance between the two data points. One data point is represented as ABCD and another is represented ABE, so that will be two. But there is no string representation. Their averages. So for that example, the solution can be we can take any random point from a cluster and represent it as a cluster head. And based on that point, we're trying to find out the closest of all the point to the cluster. So a particular point that has been selected, it will be represented as a some kind of center. So we call that center as a clusteroid. Now, selecting the cluster. So there are some rules is defined by the authors in this presentation. So these clusteroid are the point that minimizes the sum of the distance to the other point in the cluster, the maximum distance to the another point in the cluster, and the sum of the square of the distance to the other point in the cluster. So these are the few points that must be satisfied when we are defining any clusteroid for a non-Euclidean space. Okay, so this is a example. When you are using this, you are defining some distance between the some data point, and you're applying the three clusteroid criteria to each of the 4 points. So basically, you are defining the three clusteroid, and you're defining the some criteria to select the clusteroid. Okay. So by this, you can find out your cluster by selecting a AECDB as your centroid, and based on that, you can define your cluster. So how can you measure the distance between the cluster in a non-Euclidean space? You can use a clusteroid instead of centroid, and you can also take that minimum distance between any pair of point, average distance, or you can take a radius or diameter for the same. So when we have to stop the clustering, so you can take some criteria here. First, you you can take some limitation here to find out the stopping criteria, and you can apply when you are defining your clustering for non-Euclidean space. Okay, so that is all for today. If you have any question at all, we'll open this session for another 5 to 10 minutes. And one moment. Yeah, that is all for today. And we'll open this session for another 10 to 15 minutes for a question and discussion. Thank you for joining the session.